Good morning, my dear students. Today I am going to take under coordination compounds the theories of coordination compounds. Different theories are proposed to explain how coordination compounds are formed and how to predict the paramagnetic character, diamagnetic character, and shapes and all the properties the theory was proposed. So let me explain these theories. I am Dr.R.G, Professor of Chemistry, who is taking class for you. So, theories of coordination compounds we are going to discuss. Under the theories of coordination compounds, there are 5 theories are available. 1. Werner theory, who is the pioneer of to start the theories of coordination compound. Number 2, valence bond theory. Number 3, crystal field theory. Number 4, ligand field theory. And 5, molecular orbital theory. So here, as per our syllabus, only Werner theory, valence bond theory and crystal field theory only we are going to discuss, whereas ligand field theory and molecular orbital theory will be discussed under the BSc and the MSc level. So we will concentrate only first 3 theories. Please follow. So first let me take the Werner theory. Under the Werner theory, there are a number of postulates he proposed. What are the postulates of Werner theory to understand the theory? Number 1, first postulates, metals, generally transition metals. Please follow. Metals, generally transition metals, possess 2 types of valencies in coordination compound. 2 types of valencies in coordination compounds. He took Werner he took an example of cobalt trichloride .6 NH3. This is the complex example he took at that time. So, according to him, there are two types of valency. They are primary valency or ionizable valency. Primary valency is or otherwise ionizable valency. Secondary valency or non-ionizable valency. Or non-ionizable valency. Kindly follow. This is the first postulate. The second postulate, the primary valency corresponds to the oxidation state of the metal ion. We have already discussed what is oxidation state of the metal ion. So, primary valency corresponds to the oxidation state of the metal ion, and it is satisfied by negative ion generally. Here, oxidation state of cobalt is +3. The primary valency corresponds to the oxidation state of the metal ion and is satisfied by negative ion. Here, negative ion is chloride. Kindly follow. Now, third postulates. The secondary valency corresponds to the coordination number of the metal ion or atom. What is coordination number? We know it is nothing but total number of ligand present in the complex. And it is satisfied by either neutral molecules or negative ion. So, in this case, the examples of Werner, cobalt 3 chloride .6 NH3, 6 ammonia ligands are bonded to COCl3 by secondary valency. The ammonia is neutral molecules, neutral ligand. Kindly follow. The molecules or ion that satisfy secondary valencies are called ligand. So he called ammonia as ligand. Ammonia molecules are called ligand. That means molecules that donate lone pair to the central metal ion are called ligands. Kindly follow. Postulates 5. The ligands having unshared pair of electrons form coordination compounds with central metal atom or ion by secondary valency. It is stable. Secondary valency. So we know the structure of ammonia. So each one is having a lone pair. So 6 ammonia molecules having lone pair. They are providing to the lone pair to the central metal cation, the CO, cobalt. Kindly follow. 6. This is the most important postulates. Kindly follow. The primary valencies are non-directional in nature. Non-directional and in nature. And the secondary valencies are directional in nature. And thus, they give rise to various type of isomerism. This is the most important. So when we were discussing about the isomerism of organic compounds, I informed the difference between inorganic and organic compound. One of the type is the isomerism. Isomerism is possible in organic compound but not possible in inorganic compound except coordination compound. So now I am just recollecting this. So that the give rise types of isomerism we are going to see later. Kindly follow. Next. The 7th. Primary valencies are designated by dotted lines according to Werner, and the secondary valencies by solid line. Please follow, my dear students, to indicate the structure of coordination compound. This is COCl3.6NH3. According to Werner, the structure should be represented like this. Suppose in the examination of board examinations or the NEET examinations, one among the following is the correct structure of Vernier theory. If it is asked, this is the correct theory. Kindly follow. 3 Cl atom are indicated by dotted line. They are primary valency. Solid line indicates secondary valency. Actually, it should be with arrow. Arrow indicates donation. Kindly follow. Donation means they are donating the lone pair to the central cobalt metal atom. Please follow. So this is the representation given by Werner to represent the molecular formula, the structure of cobalt 3 chloride.6NH3. This is the postulates. Now, defects. What are the defects of Werner theory? Drawbacks. Number 1, it fails to explain the magnetic properties of coordination compound. Because all the coordination compounds are either paramagnetic or diamagnetic. So that cannot be explained by Werner theory. Number 2, Werner theory fails to explain the spectral properties of coordination compound. Spectral properties. Kindly follow. Colored or colorless. That cannot be predicted. The Werner theory fails to explain the shapes of coordination compound. For example, tetrahedral, square planar, octahedral. So this explanation was not given by Werner. So Werner theory fails to explain the shapes of coordination compound. So in order to overcome these problems, the next theory was proposed to by, that is valence bond theory. Kindly follow. Valence bond theory, actually we have seen under the regular bonding by Pauling. So here, postulate 1 according to valence bond theory, under the influence of ligand, that means in presence of ligand, The central metal atom or ion makes available a number of vacant orbitals equal to coordination number. That is n minus 1d, ns and np, or ns, np and nd orbital. What is the meaning of this postulate according to the Valence theory? Suppose in presence of ligand, under the influence of ligand, the central metal atom or ion makes available a number of vacant orbital equal to coordination number. Suppose total number of ligand 4, it will keep vacant 4 vacant d orbital. If it is 6, it will keep vacant 6 the d orbital. That is the meaning of this postulate. Please follow. So to understand this explanation, the postulates, I am giving the same example given by our Werner. So Werner formula we can write in this way. This is the correct way of representation of a complex. So name I can give hexaamine cobalt 3 chloride. Please follow. So for this what we need, my dear students, the first transition series elements order you have to memorize. I told you already the periodic table, what are the things you have to memorize. First one, that is the first group, S block elements, first group, second group, and P block elements, all the P block elements, and the transition series, first transition series. And the period wise, again you have to up to the first transition series, you have to memorize. It is very, very essential. Say for example, now you will come for cobalt. So it is coming under this, kindly follow this, the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. This is the first transition series. Kindly follow. This is 31 to 21. 22, 23, 24, 25, 26, 27, 28, 29, 30. This is the atomic number. So there are three information you must know. If atomic number is given, you must know to tell the name of the metal, and immediately you must write the electronic configuration. So if you give the metal, you must know the atomic number, electronic configuration. If the electronic configuration is given, you must know the metal and atomic number. This is the most important, kindly follow. So come for cobalt, it is 27. So that means in terms of the electronic configuration, I can write now it is 3D, kindly follow, scandium, titanium, vanadium, chromium, manganese, iron, cobalt. 7 d electrons. So out of 7 electrons, kindly follow here, it is filled here as per the rule 1, 2, 3, 4, 5, and again paired 7. So S2, that is 4S2. So 3D7, 4S2 is the ground state of the electronic configuration. GS stands for ground state. In the excited state, what is happening now? So that is the oxidation state. So these 3 electrons, because oxidation state is just chromium, the ammonia is neutral, so 3 Cl minus. So the Cl3, that means 3 minus, so not to be balanced, 3 plus. So 3 plus means 3 electrons are removed from the cobalt atom. So 2 s electron and 1 from the 3d electrons are removed. We are having, this is the excited state of the cobalt 3 plus. So in this case, kindly follow. So what will happen now? In the excited state, kindly follow. Now the ligand plays important role actually, but it's not given by Valence theory. So it's a ligand is strong ligand. It is getting pairing taking place. So actually all this explanation was not given by Valence theory. So it is keep vacant 6 orbital. As per the theory, so just see here 6 orbitals D2, 1s, 4s and 3p. 3p, 1 4s and 3 the 2 3d. Totally 6 orbitals kept vacant in the excited state as per the Valence theory. So in presence of ligands, ammonia, the cobalt metal ion keep empty 6 vacant orbital. That is the Valence theory. Please follow. So the same the diagram I am giving for instead of neutron molecule in the form of ion I am giving. Same configuration I am giving. Kindly follow. Now, next let me go for the postulate 2. Before forming coordinate bonds, these vacant metal d orbital undergo hybridization to form vacant hybrid orbitals. What are the orbitals undergoing? 2d plus 1, that is 1s plus 3p. Kindly follow. This is undergoing hybridization. So 2 1 plus 3 3 plus 3 6 D2sp3. Kindly follow. So D2sp3 is the hybrid orbital that is undergo hybridization. So hybridization means normally what we have to think of, it should be slightly lower, more stable than the ordinary orbital. So slightly should be written lower. So you just remember here. So according to postulate 2, before forming coordinate bond, these vacant metal d orbital undergo hybridization. Here D2sp3 to form vacant hybrid orbitals. Postulate 3. So coordinate bonds are formed by overlapping of vacant metal hybrid orbital D2sp3 and filled ligands orbital. Filled ligand, each ligand having one lone pair, 6 ammonia. So this is the complex. Kindly follow. So they are hybrid orbitals, 6 orbitals filled with electrons. Kindly follow. Then postulate 4. A strong coordinate bond is formed when these hybrid orbitals overlap to the maximum extent. So coordinate bond, strength of coordinated bond depends upon the overlapping capacity of the orbital, hybrid orbitals. So if it is here, to the maximum extent, the hybrid orbital overlap to the maximum extent. Kindly follow. So it is strong. Postulate 5. The shape and stability of the complex can be predicted from the coordination number and nature. So 4 actually sp3 tetrahedral. Again 4 if it is dsp2 square planar. 5 sp3d trigonal bipyramidal. 6 sp3d2 or d2sp3 octahedral. So this is regarding for Valence bond theory. We have a number of limitation, drawbacks. Let me discuss. It involves a number of assumptions involved. Only based on assumption the theory was proposed. It does not give quantitative interpretation of magnetic field data. Number 3, it does not explain color exhibited by coordination compound. 4, it does not give a quantitative interpretation of thermodynamic or kinetic stability of the coordination compound. Which is more stable, which is less stable, it is not giving any information. Number 5, drawbacks. It does not make exact prediction regarding tetrahedral and square planar. Please follow. There are the 4 that is ligand is present, but it is not giving any explanation. 4 is whether it is square planar or tetrahedral. This is not giving any information. Please follow. This is a very, very most important drawback of the valence bond theory. It does not distinguish between weak and strong ligand. Which ligand is weak, which ligand is strong, it gives no information. See, these are the limitations. So what we are going to see next is crystal field theory. This is the most important theory. Students, you must understand this theory. Not only you can answer any question from the coordination compound. If you want to answer, you must have clear idea about crystal theory. Let me explain. I can take same example of Vernier introduced compound, hexaamine cobalt 3 chloride, postulate 1. The crystal field theory is an electrostatic model which consider the metal ligand bond to be ionic, arising purely from electrostatic interaction between metal ion and ligand. Purely ionic in the sense the ammonia donating electron will be positive, the metal ion accepting electron will be negative, so it is ionic in nature. Kindly follow. Number 2, postulates. Kindly follow. In an isolated gaseous metal ion, that means before reacting with ligands, in an isolated gaseous metal ion, all the 5d orbital, please follow. We have already discussed under the atomic structure the 5d orbital, dxy, dyz, dzx, ds squared minus y squared and dz squared have the same energy, and are called degenerate orbital. Just you can see in the diagram. This is the energy level diagram. Kindly follow. So dxy, dy is the dzx, dxy minus y square, dzx. They are in the same magnetic field, the same energy level. Kindly follow. In an isolated gaseous metal ion, all the 5d orbital dxy, dyz, dzx, dx square minus y squared and dz squared have the same energy. All are same and are called degenerate orbitals. Equal energy. So you can just see the d orbital we have already seen under the atomic structure. dxy, dy is the dzx and ds square minus y square and dz square. What is the interesting information I want to point out here? The first 3 will be different from other 2. What way? These orbital between the axis. Please follow. dxy, dy is that and dzx between the axis, whereas d square minus y square, dz square along the axis. So this is, kindly follow, between the axis. This is present along the axis. Normally, according to valence bond theory, actually, during the explain the formation of covalent bond or coordinate bond, how it is forming, that is normally the orbital coming along the axis, the axis through which the orbitals are overlapping with the empty orbital and the unpaired electrons, when they are overlapping coming through the axis called primary axis. Is called primary axis or called molecular axis. Please follow. Molecular axis. Only along this. So that's why d square minus y square, it is shown again x and y along the axis, dz squared along the x. Kindly follow. So they are present along the axis, the 3 present between the axis. So a lot of difference is there during the formation of the coordination compound. Postulate 3. Now this is very, very important. You have to keep it in mind, memorize. In an octahedral complex, under the influence of 6 ligands, octahedral means 6 ligands, the d orbitals split into 2 groups of different energy. That is, EG orbital and T2G orbitals. Kindly follow. Actually, it is wrong to use EG and T2G, but anyhow, all books are following. All Indian author books are following, because the EG, the term symbol, and the T2G symbols are used only in molecular orbital. So, in order to use for simplicity, they are using. Actually, what is EG? EG indicates nothing but d squared minus dy squared and d z square. So that means that these two, they are indicated by E and G. Kindly follow. So whenever EG orbital means, you have to keep in your mind d square minus dy square. Kindly for d square minus y square. D square minus y square. This is d z square. When come for T2G, kindly follow 3 orbital, T2G3, EG2. So this is dxy, dyz, dyz, dzx. So this is 3 orbital. So kindly keep it in mind. So actually I have to mention here, it is d square minus y square and dz squared orbitals, and dxy, dyz and dz squared orbitals, I have to say. But all books are following, so I am following the book usage. But I am indicating, kindly keep it in mind, it is not correct to use here, it is only in molecular orbital symbol. Kindly follow. So let me start again. So that is EG orbital and T2G orbitals, where EG orbitals are higher in energy than T2G orbital. What is the why reason? EG orbital along the axis, so there is a repulsion between two. When they are nearing this, due to electronic repulsion, they will have higher energy. So T2G orbital between the axis, they will low energy. That means normally it will split into 2 groups. Kindly follow. So EG orbital high energy, T2G orbitals low energy. That is the postulate 3. In octahedral complex, under the influence of 6 ligands, the d orbital split in 2 groups of different energy. That is d squared minus y squared and dz squared orbitals, and d2g orbital dxy, dyz, dzx, where each orbitals are higher in energy than d2g orbital. Kindly follow. That is, now you see the diagram, you have a very clear idea. This is the energy level for d orbital in octahedral complex under the influence of the ligand. Kindly follow. So in the absence of ligand, they are degenerate. This is degenerate in the absence, but in the presence of ligand, it is splitting into 2 groups. Kindly follow. D squared minus y squared, dz squared, that is, we are calling it as EG. dxy, dy is that dzx, that we are calling it as d2g. So this entire difference will be given as delta 0. The total energy required is the delta 0. So that we are now explaining here. So this is the normal energy level, and from that this EG orbital going 3 times above. That's why we are calling it as plus 0.6. That is, we are assuming it is 1 delta 0. Out of this 0.6, it is going upward the EG orbitals, and the 3 T2G orbitals coming down. So it is minus 0.4 delta G. Kindly follow. This is just to give knowledge. From the normal energy level, the EG orbital going higher energy than the normal energy, whereas the 3 D2G orbital coming lower. and proportion is 3:2. Kindly follow. Now, kindly follow. I am, in order to explain clear idea, I am taking an example of hexa aqua titanium 3 plus ion. Hexa aqua titanium 3 plus ion. Why I have taken specifically hexanium titanium? Kindly follow. Scandium titanium configuration is D2S2. 3D2, 4S2. This is the configuration. So 3 plus means it is having only 3D1 electron. So only one D electron is there. So normally in the degenerate orbitals, one electron is there in the lowermost orbital. Kindly follow. So when in presence of ligands, it is getting excited. So by absorption of energy from the atmosphere, this electron getting excited from T2G to EG, it is moving. Kindly follow. So what is happening now? The energy difference we can able to measure. In the case of titanium, aqua titanium 3 plus ion, we can able to measure the energy difference. So by measuring the energy, the energy difference in the form of, kindly follow, the wave number, kindly follow, to 20,300 centimeter minus 1, that is the observed experimentally for d orbital excitation on the case of titanium complex. So if you know, kindly follow frequency wave number, we can calculate frequency, we can calculate lambda, we can calculate E. All input data we can able to calculate. Kindly follow. So now here, the molar absorption, intensity of absorption versus frequency, it is given here. Kindly plotted here. Kindly follow. Postulate 4. So kindly follow. In octahedral, the EG is higher, T2G lower. In tetrahedral, just reverse. Please keep in under mind, my dear student. In tetrahedral complex, under the influence of ligand, 4 ligands, the d orbital split into 2 groups in the opposite way, round to that octahedral complex. Opposite way to that of octahedral complex. That is, T2G orbital have high energy than EG orbital. So 3 below 2. Kindly follow. So this is the postulate of 4. That means in octahedral, EG higher, T2G below. In tetrahedral, reverse. Please follow. So this is the corresponding the energy level for d orbital in tetrahedral complex. So this is the degenerate orbital in aqueous solution. But when you add in presence of ligand, it split into this way. Kindly follow now how the difference of splitting also varies. So it is 2 times it is plus 0.4 delta 0 in the case of T2G. Whereas coming down is minus 0.6 delta 0 in the case of EG orbitals. Please follow the reverse, that also reverse. Kindly follow. This is the most important comparison. Please remember. Then postulate 5. In a square planar complex, also by square planar. This is the square planar complex. If it is, for example, any metal here, platinum or anything, so this is the square planar. In a square planar complex, under the influence of 4 ligands, the d orbital split into 2 groups of different energies in the same way as octahedral complex. So it is similar, identical to that of octahedral complex. That means EG higher, T2G lower. But only thing is with weak ligand field, with weak field ligands. With weakly filled ligand means the energy difference will be very low. That is the important information. Kindly follow here. In this case, so this is the energy level diagram for the d orbital in square planar. So EG orbital above, T2G orbital below, as in this case, as usual degenerate orbital aqueous. in presence of the ligands split into this. As usual, it is to 3/3 above, 2/3 below. So above plus, below minus is indicated is the magnitude, but actually speaking, it is the difference is nothing but delta zero. It is the crystal field theory, crystal field energy, we will call it as. Kindly follow. Now, the most important postulate we are coming. Please follow, my dear students. This is the most important. The magnitude of delta zero depends on three factors, namely nature of ligand. When you say nature of ligand, means weak ligand or strong ligand. Number 2, charge of the metal ion. +1, +2, +3, like that. It depends on the charge. The delta value depends. And also, the position of the metal in the first, second, and third row of transition series. The delta value depends upon the position it is occupied in the periodic table. First transition series or second transition series or third transition series. Depending upon the position, delta zero value vary. I will explain with the example, you have clear idea. Before that, kindly follow. I am giving here the list of ligand measured with the help of spectrochemical series. This is the weak ligand is here and strong ligand is CO. Kindly follow. So actually, strictly speaking, kindly follow, in the carbon CO, CN, they are strong ligand. In the case of nitrogen, O, NO and NO2, they are strong ligand. But again, exceptionally, only these three, the comparatively strong. These NO2, depending upon the conditions. Kindly follow. All other ligands are weak comparatively. Please follow. This is spectrochemical series. So you memorize CN, because often it will come only in the complex. CN, CO will come, NO2 will come, OH will come, the halogen will come, water will come, and ethylene diamine will come, ammonia will come. Kindly follow. So here, ammonia is a weak ligand. So here, let us assume here, these four, you can memorize, they are strong. So how to remember, I will tell you simple. So you go for the second group, lithium, beryllium, boron, carbon and nitrogen. Under the carbon, two ligand, CO, Cn, memorize. Under the ligand 2, NO2 and ONO. So these four are strong ligand. Please memorize. All other ligands are weak. Kindly follow. Now let me come for the factors I have given already. Crystal field splitting by various ligands. Depends upon the ligands, the delta zero value vary. Kindly follow. So just take complex chromium, that is hexachlorochromium 3 minus, hexaquachromium 3 plus, hexachromium 3 plus, hexacyanochromium 3 minus. So central metal ion is common. Only ligand I am changing. Kindly follow. When I change the ligand, see the energy. It is 163 kilojoule per mole, 213 kilojoule per mole, 259 and 314. Kindly see strong ligands, higher energy. Kindly follow. The splitting, kindly follow, is higher if ligand is stronger. Please follow. This is the information we are getting from here. So the delta zero depends upon the strength of the ligand. Higher the ligand strength, higher will be delta value, zero value. Lower the ligand, lower will be the delta zero value. So this is given in terms of centimeter minus 1. That is not necessary to memorize. So this value is not memorized. Only the magnitude, higher or lower, you have to memorize. The second case, the crystal field splitting by different oxidation state. So that means delta 0 depends upon the oxidation state of the metal ion. So here I am taking a specific example of +2 and +3 oxidation state of cobalt ion. Hexa aqua cobalt, the N plus ion. N, why I am putting N plus? Here 2 plus, here 3 plus, though that's why I am putting the N plus there. So for 2 plus 111 kilojoule per mole, for 3 plus 222. Kindly follow. It is simply double the time of the change in oxidation state. So higher oxidation state, higher will be the delta 0 value. Splitting value, energy difference is higher. Please follow. And third one, position. Delta 0 depends upon the position of the metal ion. The crystals will splitting by change of metal ion. So here in the come for the cobalt family, in that series, electrochemical, the first series cobalt, the next rhodium, then iridium. But complex, the ligand I am keeping common. 6 ammonia, 6 ammonia, 6 ammonia. So only change here it is metal first transition series, rhodium second transition series, iridium third. So what is the observation here? When you go down, energy difference increases. That means the elements present in the third transition series will be having higher delta 0 than second, which is higher than the first ionization energy. Please follow these three important information. And kindly follow. Now, I want to give one more important information. This is most important. Normally, it is not given in our book. It is given only in MSc book. Why I am giving here? Because many example you are finding very difficult to understand the explanation, because even books are giving the very that is the wrong answer it is given, and then probably would teach, I don't know how they are giving explanation. For simple example, let me point out here. So copper tetraamine copper sulfate, as per if you go according to crystal field theory, kindly follow, it will be square planar. It will be predicted by square planar. But actually it is observed, it is the predicted by tetrahedral. It is predicted by tetrahedral, but actual it is observed is square planar. It is given in the book, but no explanation given in our book. Kindly let me repeat again. Hexamine copper 2 sulfate, as per the crystal field theory, you can predict as it is a sp3 hybridization tetrahedral. But actually the shape is square planar. No reason is given. So in order to explain these the explanations regarding these defects, the John Turner distortion was introduced to explain these facts. What is John Turner distortion? Kindly follow the elements, that is transition at metal atoms, having a D4 configuration in the ion during the formation of complex, or D7 configuration, or D9 configuration. Please follow, my dear student. This should be memorized. D4, D7 and D9 configuration. If it is present, so that shape, theoretical shape, will be different from the observed original shape, because there is some distortion taking place that is predicted by John Turner distortion. So let me take example. D4 means, that is, you can say scandium, titanium, vanadium, chromium. So in the chromium, D4, kindly follow. D4. So in that case, D5, S1, it will be coming. Kindly follow. So chromium 2 plus, if you take any example of complex, So you will have the 4 electrons. Kindly follow. Unpaired electrons. Now what is the important information here I want to give? So we have already seen. First ground level you are writing the electronic configurations for the neutral metal. Then oxidation state you are writing. Then in the excited state they undergo the actually empty d orbital, that they undergo hybridization. These are all we have discussed already. Kindly follow what will happen now. When the ligand, when you look into that, if a ligand is a strong ligand, kindly follow, it will push the electron to pair. How can you say kindly follow? To understand, you understand this one. See here, let me take octahedral. Please listen, my dear students. You should be very, very careful. D squared minus y squared, d z squared. This is dxy, dyz, dzx. That is T2G, this is Eg. So what will happen? Suppose we are having electron here. If a ligand is stronger, this difference, delta 0 value is, we have explained already according to postulate of crystal field theory, greater. So energy difference is greater. In that case, so what will happen now? These 4 electrons, kindly follow. In the case of strong ligand, if you fill up, what will happen now? So it will go here, that is one by one, we have to fill up as in the case of ordinary electronic configuration. Kindly follow. So let me take copper sulfate. Then you can understand that. What is the copper sulfate? That is D10S1. D10S1, that is the copper ion. So tetraamine copper sulfate. So it is the configuration is copper 2 plus. So it is D9. So let me take D9 configuration. Kindly follow. So what will happen now in D9 configuration? So tetraamine, kindly follow. So ammonia is a weak ligand. So here what will happen now? The normally if it is a strong ligand, the crystal field energy is longer. Weak ligand, it is shorter. So what will happen now? There is nothing there. So only left 4 ligand is sp3. Kindly follow. In the case of copper sulfate, so that is the tetraamine copper sulfate, NH3, 4 and sulfate. So the lower is sp3, that is sp3 hybridization, 4 empty. So what will happen now? From ammonia there are 2 electrons will occupy. Kindly follow. So what is the hybridization? sp3. sp3 means tetrahedral. But if you observe your book, it is given as square planar. Now only I am going to give answer for that. What is the answer given is as per the MSc John Taylor distortion. Kindly follow. These 2, these 3, this is Eg, this is T2G. Please follow. Eg, T2G. Eg, T2G. Kindly follow. So in this you consider only 2 Eg orbital. Why? Because only these orbital along the axis moving to form coordination by coordination compound due to overlapping of orbitals. Kindly follow. So this will only affected is strongly by the ligand field strength. So just compare now. Unsymmetrical. Please follow. One is empty, another is single. Just see here in this case, both are same, symmetrical. Kindly follow. Here, unsymmetrical. My conclusion is, if look at the Eg orbitals, if they are unsymmetrical, there is a distortion takes place. Kindly follow. Distortion takes place. If it is not unsymmetrical, no distortion takes place. So in the case of copper tetraamine 2 sulfate, it is unsymmetrical. 2 electron here, 1 electron, so unsymmetrical. That's why tetrahedral becomes in the form of square planar, getting distorted into square planar. So no other further explanation should not be given. Simple one word. Due to John Taylor distortion, tetrahedral converted into the distorted square planar. Please follow. So now let me concentrate now. D4 and D7 and D9. Kindly follow. In the case of D4, only weak ligands, kindly follow, weak ligands only operate, will be useful. Only weak ligand. Weak ligand means the level will be very, very close. Very, very close means, what will happen now? The energy level is very, very close, means there are 4 electrons D4, so occupied 1, 1, 1 and again 1. So then it's very, very close energy. So it is filled in as per single electron, that's we are seeing here. In the case of weak ligand. Kindly follow. So now there is unsymmetrical. So any configuration having unsymmetrical, it will give distorted structure. So D4 configuration will show distorted structure in the presence of weak ligand. But in the presence of strong ligand, what will happen? It has to, the delta 0 will be strong. So this should be paired in the form of this pair. Kindly follow. So no complex will be formed. Kindly follow. So very interesting. Let me go for the second, D7. In the case of D7, only strong ligand, this is only weak ligand. Here only strong ligand will operate, will affect this. When strong ligand means, what will happen? This will be pairing this way. Kindly follow. This is going out, coming here, pairing takes place. How can you imagine this pairing? Kindly follow. 3 here, 2 here. Strong ligand. Let us, I told you strong ligand like Cn. So totally how many electrons? So totally it is 7 electrons. So 1, 2, 3. Kindly follow. I am filling up as per the rule. 4, 5, 6. And it is going 7. Kindly follow. So only 1 electron it is present there. Kindly follow. So now see here. I am writing here in this form. So this imagination, you have to bring it here. You have to imagine in the presence of strong ligand, this is pairing and we are getting only 1 electron here. 3 paired electron, 1 unpaired paramagnetic in character. This is 4 electron paramagnetic. This is 3 paired, 1 single electron, again paramagnetic. What will happen here in this case? So D ligand is 4, DsP2. Kindly follow. Please follow. The next one, D9. Example we have discussed already. Example copper. Electronic configuration is copper-like. So in this case, both weak ligand and strong ligand, this is operating. So in both cases, there is unsymmetrical. Kindly follow. In the case of weak ligand, this is not pairing. Only in the case of strong ligand, the pairing taking place. Kindly follow. Pairing taking place. That's why 1 empty. So DsP2 it is forming. So in the case of here, whether it is strong or weak, there is nothing pairing. So unsymmetrical. Kindly follow. So let me finalize now. Kindly follow. In the case of D4, according to John Taylor distortion, please note, my dear student. Please note in your notebook. According to John Taylor distortion, in the case of D4 configuration of ion, the metal ions, now there is only in the presence of weak ligand, we are predicting the shape of the orbital, hybridization, paramagnetic character works. So only weak ligand, it works. D7 only in the strong ligand, it works. Whereas in the case of D9, both weak and strong ligand work on this one. Kindly follow. So, according to crystal field theory, what you can predict now, you can easily predict what are the ligand name, ligand strength, the magnetic number of paramagnetic unpaired electron, you can predict paramagnetic character, you can predict, and the shape, hybridization, you can predict. From the shape, you can predict the shape of the molecule, you can predict. So all information you can predict here with the help of the Untitled theory. I hope you have understood very clearly what is the limitation, drawbacks of Untitled theory. It fails to take into account of covalent character of bonding between ligand and central metal atom. It fails to take into account of covalent character of bonding between ligand and central metal atom. Please follow. So, my students, I am come to the conclusion. My dear students, you are looking for the first time my channel, Neat Chemistry by Dr.R.G. Kindly click like and kindly click subscribe to motivate me. So for you, I want to give one information. This channel I have started to help poor students of India, specifically in chemistry. As a professor of chemistry, I am doing this. So for NEET preparation, so I will help you so that you will get 180 out of 180 marks you will get definitely if you go through my channel. I can give guarantee. And even in your board, you will get 100 out of 100. Please follow. Kindly share here. So one more important information I want to convey here. I have included the chapters from 8th standard, 9th standard and 10th standard chapters under the first unit basic concept of chemistry. Under the basic concept of chemistry I included. Why? Because in the book, plus one book, it is given only 16 pages. But I have taken nearly 17 lessons, 16 or 17 lessons I have taken, 17 hours. Kindly follow how much effort I have taken for that. So that you will have a very fundamental basic idea, everything you will have from the basic concept of chemistry. Unless you know basic concepts, you cannot study chemistry. Please follow. So let me come the other side. That is students who are waiting for NEET entrance examination conducted by the Government of India for this academic year. That is, students who are studying plus 1, plus 2 and plus 2 completed student. For you, I have a good news. We are running a coaching center, Vernier coaching center in Pondicherry for the last 21 years. And we had our achievements for the last 20 years. It is given in our website, vetri.us. If you go to our site vetri.us, in Tamil Vetri Namade, in the home page you can see all our records in photograph. Kindly follow. One of the important record I want to give, every year 10 to 20 students we are sending to Japan Medical College from the beginning, and 150 to 200 students are going other medical colleges. Few students are joining IIT, hundreds of students are joining other engineering colleges. In 2003, one of our students, R. Srinivasa Raghavan, came All India first rank in JIPMAR. At that time, NEET common entrance examination was not there. This is our main achievement we want to say. So for students who are waiting for NEET entrance examination of Government of India for this academic year, I want to inform regarding vetri.us three important features of vetri.us, so that if you go through our vetri.us, if you study our vetri.us, you can score minimum 600 to 700 marks. 100% you will become a doctor. I can give guarantee. It is a low cost. So even poor people can afford this one. So let me come for the first feature. This vetri.us is containing 200 video lesson, 200 video test, unit test, 200 video lesson, 200 unit test. Regarding the video lessons were taken by professors with a doctorate degree and 20 to 30 years of experience in IIT and medical coaching, as well as BSc, MSc, MPhil and PhD students they are teaching. So they can give very clear idea in the lesson. You can feel classroom coaching when you see the video, that you can observe there. Everything will be in form of notes. It will be in the slides. Everything will be in the abstract form of notes, like just like in Tamil you say Konar. Like that it will be in notes form. So if you want to take notes, just touch the video. You can take all notes. Again touch, it will run. So any number of times you can view the video. Kindly follow. Number 2, we are giving 200 unit test. That means each unit, that each subject having 50 units and each unit having 2 tests. Kindly follow. That means kindly follow. Example. Suppose let me take this example, coordination compound. Suppose you want to go for coordination in the unit. There are 2 tests given. Test 1 and test 2 will be given. 45 question here, 45 question here. So first test, you can write 45. So in the 45 questions, kindly follow, all the questions are taken from previous 20 years of question papers of IIT, AIMS, AFMC, AIPMT, MSET Andhra, Karnataka, Delhi, Tamil Nadu, Pondicherry. All these question papers, only question papers are taken from the 20 years question papers and framed as 200 unit tests. You can ask me, what is the advantage of framing the question paper? We have observed for the last 6 years, 75 to 80 questions, same questions are repeated. Same questions are repeated in NEET entrance examination conducted by India that come from our Vernier question bank. That means Vernier is giving you 320 marks to you. So if you are a good student, you can get easily 300 excess. So 600 to 700 you can get very easily. So you can become All India rank. So you can join JIPMER, AIMS or the Vellore Medical College, or any other medical college you want, you can join. Please follow. That is the most important information. Kindly follow. The second important feature is the test, unit test. What is the unique feature of the test we are conducting? So in the unit test, there is a menu called attempt. If you click attempt, the window will open. It will say information. It will give information. You have this unit contains 45 questions. Each question carries 4 marks. If your answer is correct, 4 marks awarded. If answer is wrong, 1 mark subtracted. Are you ready? It will ask. If you say OK, click OK, immediately a window will open. Kindly follow. Your window will open. In the window, you can see question number 1. Option A, option B, option C, option D. Again, there are 3 menus are there. Below that, there is 1 to 45 question number 1 to 45 number in yellow color will be there. Kindly follow. This you can see in window. Please follow. This provision is not given in any online coaching. When you are click the video, automatically you have to click next, you have to go, that's all. But this you cannot say. So what is the advantage of this seeing this window? You are seeing A, B, C, D, and there are 3 options. Center is complete. This is next. This is the reverse. You can push it, so you can go. So what happens? Suppose if you feel A is the correct answer, click the A. Immediately, the kindly follow 1 to 45 number will be there. The number 1 will change from yellow to green color. Yellow to green color. That means you have attended the question number 1. So what is the advantage of the second question will be blue color, all other question will be yellow color. What is the advantage? Suppose after attending 50% of the total questions, say for example 20 questions, you can see directly 20 question will be in green color, 25 question will be in yellow color. So which question you have not attended, which question you have attended, you can see directly. But this provision is not there in other online coaching. Kindly follow. After finishing all the questions, 45, click complete. Immediately a window will open. It will give information regarding marks. let us say 160 by 180. You are getting 45 into 4, 180. So in chemistry, coordination compound, you are getting 160 marks. That means 20 marks you are losing. 5 questions, you have done some mistake or you have left. So you want to know, verify. Kindly follow. This is another important feature which is not available in other online coaching, that is review menu. So we are getting marks, 160 by 180. The nearby this menu is there, review menu will there. If you click the review menu, immediately a window will open. A window will open. Kindly follow. So this is menu, review menu is not available. This is self-assessment. You can yourself verify whether it is right or wrong. But in other online coaching in India, you cannot have this feature. You cannot assess yourself. Kindly follow. So question number 1, you can see option A, option B, option C, option D, and also correct answer also given in yellow color. And below there is the video solution. Please follow. If you have answered A is the correct answer, that color will be blue color. Your answer will be in blue color. The correct answer will be in yellow color. So how can you identify if your answer and correct answers are same? Correct. If it is different, your answer is wrong. So you can assess self-assessment. Whether you are right, where you have done mistake, you can easily identify by seeing this window. This provision, I told you, not available in other online coaching center. Kindly follow. The most important feature which is not available in other online coaching is the solution, video solution. In other online coaching center, they are giving the answer a single word they will give, or one line typed matter. They will give wherever, suppose A is a correct answer, in the option A, they will give some typed matter of 1 line or 2 lines they will give, that's all. You can kindly verify and check. What I am giving is 100% truth I am telling you. So our case, now you click video solution. Please follow. You click video solution. Immediately, you can see the professor standing in front of a board. On the board, you can see the question, you see the option. And he will read the question, he will read the option. He will explain what topic and what subtopic it is asked, what is the basic principle, what are the definition, what are the formula, what are the differences, what is the diagram used, everything, the short route, everything he will explain. 10 to 15 minutes it will run. Please follow. Just like in the case of video lesson, this also you can stop and take notes. You can stop and take note. This is our important feature of review menu. This is not available in any other online coaching and leading coaching in India. This is the most important. Kindly follow. As I have told you, low cost is only we are collecting 10,000 rupees per year. Only 10,000 per year. Now, my dear students, before going there, finishing, I want to give some guidelines for you. How to attend the NEET entrance examination. So, you have to follow 3 steps. Please, students, just have it in mind. So, you get more marks, this step you have to follow. Step number 1. So, you have to 1, 2, 3 steps. First step, follow the order of botany, zoology, chemistry, and physics. This is the order you have to attend the question. So what? Go botany, go zoology. If it is combined, you go again combine. Then chemistry, then physics. Please follow. Only 100% known question you can attend first. Over. First step over. Right? Then second step, go for difficult questions. Theoretical question, think twice or thrice, and if you feel it is 80% worth correct, you can put tick mark. Otherwise, don't allow the answer the question, leave it. The third step is, you go for physics and chemistry where only problems, you have to attend the problem now. Chemistry, 1/3 of the questions will be problem, physics, the 50% will be problem. So use suitable formula, substitute, apply suitable units, calculate, find out the answer. If the answers are coinciding with the options given in the question A, B, C, D, it is correct, you can click the question. If it is not right, again verify the calculation, check up. If it is okay, tick, otherwise don't. So it is not necessary to answer all the 200 questions. Please follow. All the 200 questions not necessary, you have to answer. Please follow. So if you follow these steps, definitely you will get 600 to 700. I can give guarantee for you, my dear student. I told you, we are collecting only low cost. Even a very poor family can offer 10,000 per year. So you can pay 10,000 rupees in the name of Santi, Director of Vetri Coaching Center, Indian Bank, account number 712719471, IFC code IDIB 000P134, cell number 989417645. So if you want to, just also your WhatsApp number, contact me for any clarification. Thank you very much for the kind cooperation. See you again in my next chapter. Bye-bye.